We have multiple sockets connecting to our blockchain application now. However, we still have to get our sockets to synchronize their blockchains with each other. To get our sockets to communicate and send the blockchain-specific data, we use a send method of the socket object. The send method allows us to send an event to the relevant socket containing a stringified message. In this model, we'll be sending message events to sockets. But likewise, we need to make sure our sockets are prepared to receive those message events. We handle those message events with an event listener. Let's create this event listener within a function called message handler that has one parameter, a socket object. So let's put it at the bottom and we'll call it message handler. And its one parameter is a socket object. With this socket object, like our other event handlers, we chain the on function. So we call socket.on, and then the first parameter for this is a string, which represents the event we want to handle, which in this case is a message event triggered by a send function. For the second parameter of the function, we have a callback that has one parameter, which is a message object that populates because of the on event listener. First up, within this, let's declare a new constant called data. And since our messages will be stringified objects, well, let's turn that back into a regular object by using the json.parse message function. With this method, we transform the stringified JSON into a JavaScript object that is now being stored within the data variable over here. Great. Now let's add a console.log of that data to make sure that we're receiving it. For the first parameter, let's have a data string. And then for the second parameter, let's log the data itself without the string. Now that we have this message handler, let's attach the handler to our connected sockets. All of our sockets run through the connect socket function. So let's attach the message handler here. We'll call this .message handler, and then we'll pass in the socket object that is being passed to the connect socket function itself. All right, great. Now each of our sockets are ready to receive message events. However, we still have to actually send the message event containing the blockchain object to the sockets that we connect to in the peer-to-peer system. To do so, we'll use the send function on the socket object. We'll want to send a message to each socket that our WebSocket server receives as a peer connection. Therefore, let's call socket.send for every socket that's connected to in the connect socket function. The send function takes one argument, which is the string message it should send. For us, the useful thing that we want to send from this P2P server class is its own blockchain. So we'll send this .blockchain and then the chain object within the blockchain instance. Recall that the send method takes a string though, and the blockchain's chain is an object. So let's turn it into a string with a json.stringify method. So that is json.stringify. And we wrap that around our this.blockchain chain. So overall, the socket.send sends json.stringify and then this.blockchain.chain. Great. That should be enough to see messages containing the respective blockchains of our socket connections to get logged to the console. For our test, let's try growing the blockchain of one node by a couple blocks. And then let's see if new blockchain peers that connect to that first app receive a message containing that entire blockchain. After all, when that second instance fires, it will run connect socket and it should get the blockchain of the first instance. Let's head to the command line and give it a shot. In our command line now, go ahead and kill any running instances that you currently have, and then let's fire up one instance with the npm run dev command. All right, great. So we have one running on the default ports that we've set, and then let's grow this blockchain a little. So let's open up Postman now, so that way we can send a post request to our application to add some new blocks to this currently running blockchain application. All right, here we are in Postman. Hopefully you have the mine endpoint saved from before, but don't worry if it's not there anymore. Remember to go into the body section and select raw, and then pick JSON, application JSON for the type of data that we're sending. Make sure it's a post request, and then choose localhost 3001/mine for the actual endpoint that we're hitting. All right, now let's click send a couple times to grow the blockchain for that first instance. And as we do so, as the response, we have 2 more blocks added to this chain, which are both foo blocks. Great. All right, now let's head back to the command line. And what we want to do is launch a second instance now, and then make sure that that second instance receives an immediate message that contains the entire blockchain from the first instance. So in the second tab, let's run a second instance. And this time we'll need to use environment variables. So let's change the HTTP port of the first one to 3002. Let's change the peer-to-peer port to 5002, since that one isn't being used yet. We have one peer, which we'll call peers, and that is the address of the first instance, which is WebSocket or ws://localhost port 5001. So have a colon over here. And then finally, we run npm run dev, and here we go. And as we do so, well, what do you know? We immediately get some data as a message. And indeed, it's the stringified blockchain object from our original blockchain instance. Excellent. And now if you look at the first tab where the original instance was running, well, check it out. We also have a message in here, which is the blockchain of the new instance that we just connected to on this WebSocket server as a peer. Great. Now that we have blockchain communication in our peer-to-peer server in our network setup, let's move on. This is really cool stuff already, but it's only the tip of the iceberg to supporting decentralization through multiple blockchain instances for our system. With this, we'll make sure that these messages actually update our blockchains and they all agree on one, because the second instance is sending its small blockchain to the first one, but the first instance is sending its large blockchain to the second one. All right, let's get to the functionality of updating our application's blockchains as they receive them from their peers next.